All right, sorry about that. I have limited time on this app that I'm using to record this. But we left off with this parallelogram, which again is area base times height. We found the perimeter, again, 2 times 21 plus 2 times 17. That'll add up all the sides for us. Then we left off with the area. Again, area has to use base and height, which have to be perpendicular. We didn't have the height here, so we had to get it using some other method. So I used this right triangle that it was a part of, along with a squared plus b squared is equal to c squared. And we solved that for the missing height, and that worked out to be 15. So now once I had that, I had the base and the height. So when I multiply those together, that'll give me the area. So I do on my calculator 21 times 15, and that'll give me the area of the parallelogram at 315 square units. So that's 315 for the answer here. 315. There we go. And on to the next page. So then again on here, I need to find the perimeter and the area. So the perimeter, just like before, again, opposite sides are going to be the same, so that means this side will be 23. The only issue here is I don't know what this side is, but I can now find it again using this right triangle right here, of which it's the only missing side of. So I can use a squared plus b squared is equal to c squared to figure out what that is. That's the c now. So let's see. This would be the a, this would be the b. I'm looking for the c. So again, over here I would do 7 squared plus 24 squared and then what I'm looking for is that side, which I'll call c squared. So I do this part of my calculator, 7 squared plus 24 squared, and then I'll set c squared equal to whatever that is, and then I'll have to square root both sides. So let's go to the calculator now. 7 squared plus 24 squared, and I end up with 625. So that means c squared is equal to 625. So like I did in the previous problem, to get rid of that squared on there, I must square root both sides. So I'm going to square root this side, and I'm going to square root that side. So when I do that, I should end up with the side that I need to find the perimeter with. So square root is 625. Again, square root 625. And then I end up with 25. So that means c is equal to 25. So again, if this is 25, so is this. So that goes into then my perimeter calculation. So let's do that. Perimeter would be 2 sides of 23. Plus 2 sides of 25. So 2 times 23, 2 times 23 plus 2 times 25. 96 is the perimeter. That's equal to 96. So now the area on this, I need base times height again. Area is equal to the base times the height. So base and height have to be perpendicular. So now if I use this as my base, notice that the 25 is not perpendicular to it. So you actually have to go outside the parallelogram here to this. So this 24 is perpendicular now because of that right angle symbol to this base right here. That means this is my height. It's on the outside now, but it's still perpendicular to it. So for the calculation, it would be equal to the base of 23 times that height of 24. So I would do 23 times 24. 23 times 24. So I end up with 552. So that's equal to 552. That's 552, believe it or not. So down here, one more parallelogram problem. So I'm gonna, let's try this one. This is interesting because of that 45-degree angle. So let's see, the perimeter's easy because I have the sides. Again, opposite sides have to be the same, so that means this side's 25. This side would be 16. So if I wanted to add up the sides, again, I would do 2 times 25 because there's 2 sides that are 25. And then I would add on to that 2 sides that are 16. So 2 times 25 plus 2 times 16. 2 times 25 plus 2 times 16. And that is equal to 82, so that's the perimeter of that parallelogram. Alright, area is going to be a little bit harder. So I need to use base times height, because that's what I've been using. Base and height still have to be perpendicular. So I'm going to use the 25 as the base. Notice the 16s are not perpendicular to that 25, so they are not the height. The height I'm going to use is this height right here. Make it perpendicular. So that's going to be my height. So now I notice that I have that 45-degree angle as a part of a triangle. Not only that, I have that 45-degree angle as a part of a right triangle. So that is a 45, 45, 90 triangle. That's one of those special right triangles where all you need is one side to find the other two. So in this one, I know what the hypotenuse is and I need to find a leg on it. So you have to remember from last unit, to go from the hypotenuse to the leg, you're going to have to divide by the square root of 2. So that means I need to take that 16 and divide it by the square root of 2. So let's do that. I might have to rationalize that. Oh yeah, I'm going to have to rationalize. So 16 divided by the square root of 2. So no radicals are allowed in the denominator. So I have to do this process called rationalizing the denominator. That's where I multiply by root 2 over root 2. So up top I'd multiply straight across. 16 times root 2 is 16 root 2. Then in the denominator, root 2 times root 2 is the square root of 4, and the square root of 4 is just 2. So those radicals kind of cancel each other out. Then I can divide the 2 into the 16, that'll be 8 root 2. That ends up being my height. So I would probably just multiply that in my calculator. So that is my height right here at 8 root 2. So now base and height, I have them. The base is this 25. And then the height I just found to be 8 square root of 2. So I would just plug it into my calculator just like that. And probably have to round the number. We'll round it to the 10th, the first decimal place. So 25 times 8 root 2. So just like that. 25 times 8 square root of 2. Nope, don't want to do that. 8 root 2. So I'll round it to the 10th, so I'll call that 282.8. So 282.8 is the area. So that was our last parallelogram. Alright, so next we're going to look at a triangle. And the way I want you to think of a triangle is that a triangle is basically if I take a parallelogram and kind of cut it in half with this diagonal. So now when I take this part off, now I'm left with this part here. So this is the same as this over here. So I want you to think of a triangle as half of a parallelogram. So we just cut a parallelogram in half. Well, remember the formula for the parallelogram was base times height. Well, now if a triangle is half of a parallelogram, that would mean its formula has to be half the base times the height. That half, believe it or not, is very hard for kids to remember. I'm not sure why. So let's take a look at an example. So first, again, it asks for the perimeter, the distance around, along with the area here. So perimeter is just consisting of what this side that's 10, plus this side that's 9, plus this side that's 12. So that's going to be 10 plus 9 plus 12. 10 plus 9 plus 12. So I can quickly figure out what that is by doing 10 plus 9 plus 12. So 10 plus 9 plus 12. That's 31. So that's the perimeter of the triangle. That was easy. Alright, area is going to be a little bit harder. So let's see, I'm going to do 1/2 the base times the height. Base and height still need to be perpendicular. That's going to be true for the next 2 units. So 1/2 the base times the height. And they have to be perpendicular. Alright, so let's see, 1/2. The base I'm going to count as this 12 right here. So I'm going to use that as my base. Then my height has to be perpendicular to it, which would be this guy. I can tell it's perpendicular because of that right angle right there. So I'd do that as my height. So this, and if you want to do that on your calculator, you could do 12 times 6 divided by 2, or you could do half of 12, then multiply that times 6, or you could do 0.5 times, I'd probably do 0.5 times 12 times 6. So don't forget about the 0.5. So 0.5 times 12 times 6. And plug it in just like that, and there you got your area of 36 units squared. So again, that's the amount of squares that fit inside. 36 squared units. Here again on number 2, I might got missing side again, but again it's a right triangle. So I'm missing the side to find the perimeter, but I quickly notice it's a right triangle where I know 2 of the sides. So I can use Pythagorean theorem then to figure out what that missing side is again. So how many times have we done Pythagorean theorem now? I'll call that x. So x squared would be a leg, that would be an a or b, and 6 is the other leg, and that's going to equal then the hypotenuse, which is 10. I'm going to square that. So again, algebraically, I'm going to have to subtract that 6 squared from both sides. So I'm just going to go straight to the calculator. 10 squared minus 6 squared. 10 squared minus 6 squared. And that leaves me with 64. So then I have to square root both sides again, which means that missing side must equal 8. So this is equal to 8 right here. So what I can do is I can find the perimeter then by just adding up the sides. I just found that 8 side. I got a side that's 6 and then a side that's 10. So that's basically 14 plus 10, which is what, 24? Alright, area on this, again, I'm going to use 1/2 the base times the height. Base and height again have to be perpendicular. I'll say that every single time. I do have some perpendicular measurements here, so I don't have to find one. So I see the right angle right here, which means that this is my base and this is my height right here. So plugging it into the formula, it would be 1/2 6 times 8. Which is equal to 24. And that would